You're being recorded. So yeah, this is review number 8 right here. So basically you got a ball that's falling, but this is the kind of challenging part to this. It's falling at an angle of 30 degrees with respect to, it's 30 degrees below the horizontal. It's 1.1 meters above the ground. And all right, there you go. So this is a projectile problem. I do my Voiviagits and all that fun stuff. And so what I'm going to do is I'm going to establish an origin. I'm going to choose my origin to be where the object starts, because here's where the problem starts, here's where the problem ends. They want to know also how far does the ball travel across before reaching the floor. So, okay, so and the problem's going to end right here. So I'm going to split this vector up now into its horizontal and vertical components. This is going to be Vx. And then this is going to be V naught Y, right? Using trigonometry, we can find out Vx is going to be V naught cosine theta, or that's going to be Vx is 2 cosine of, then the angle. So you got a line going across here. You got basically like an X, right? You got an X kind of happening here like this. So if this angle is 30 degrees, that means this angle must be 30 degrees. That's using geometry. So yeah, that's going to be 30 degrees, like that. So that means this is going to be 2 cosine of 30 right there. That's Vx, and then I got V naught Y. V naught Y is going to be a similar thing. It's going to be V naught sine of theta. So that means then V naught Y is going to be 2 sine of 30, and that ends up being 1. However, I need to be careful because this is pointing down, right? This is why it's so important to draw a picture. So it's going to be negative 1 meter per second there. And then this is meters per second. I don't know what this value is. It's something. So, and then I can plug this in there. That's going to be my Vx is 2 cosine 30 meters per second. And then my acceleration is negative 1 meter per second right there. I put my origin here where the object starts. So I'm also going to plug in then that my origin, so if that's true, my initial position is 0 then, and my initial position in the horizontal direction and my initial position in the vertical direction is going to be 0. I think I only need a couple more things. One of them is the acceleration. It's a free fall problem, so the acceleration will be down, right, at negative g. So my acceleration is going to be negative 10 meters per second squared. And then lastly, I do know my final position. The object starts here and ends here in the vertical direction, right? It's going to end right there. So I know then that this has to be, my final position is going to be this. So there's my final position vector. And I know that distance is 1.1 meters. So my final position is going to be negative 1.1 meters. Now to solve this, I'm thinking the best equation to use is going to be y. So I'm first going to find out what the time is. Once I got the time, I'll plug it in there, and that's going to give me, that's going to then, be how I solve this. So y equals y naught plus v naught yt plus 1/2 ay t squared. Okay. So now plugging all this in is going to be y equals, y naught is 0, plus v naught y is negative 1, so negative t. So it's actually just going to be minus t. What is with erasing? Erasing is having issues. There we go. Minus t plus 1/2 times the acceleration, which is negative 10 t squared. And my final position is negative 1.1. What do I got here now? I got, so this all simplifies to 0 equals negative 5t squared minus t plus 1.1. So I got a quadratic. Let's break out Wolfram alpha. So this is going to be Wolfram alpha. And what do I got here? Negative 5 minus t plus 1.1. So there we go. I guess I could just do negative b plus, but this is fancier. So negative 5t squared minus t plus 1.1. So there's my graph, and looks like 0.38. I'll say 0.38 is my time. So that's the non-negative one. That's the one that's going to make the most sense. So 0.38 is my time, but that's not the right answer. That's just the time, because now I'm going to use that time and plug that into my position function in the horizontal direction. So my final position is the initial position plus vxt. Plugging all this in, so it's going to be my final position is 0 plus my position 2 cosine 30 times the time, which is 0.38. So my final position is going to be 2 cosine 30 times 0.38. So 2 times cosine of 30. Hopefully that's in degrees. Times 0.38. I hope that's in degrees. 0.66. So 0.66. Is that right, people who know?
So, yeah, that's the answer I just got after.
Thank you. Awesome. So there you go. All right. I'm going to stop recording now.